All right, you guys, we are starting a new and the last topic in polynomial operations. Be sure to take notes. So there will be a note check done on the day of the test over multiplying and dividing polynomial notes. So make sure you have those done, highlight important information, ask your questions, and then summary and reflection in your notes. So yes, we're still in Unit 6 and it's polynomial operations. And like I said, today we're dividing polynomials. So first, before we begin, I want to go over some exponent rules, and we've seen the exponent rules for multiplication. So remember, when you multiply, x to the fifth means there are 5 x's being multiplied, and x to the second power means there are 2 x's being multiplied. So since I do x to the fifth times x to the second power, I am multiplying a total of 7 x's, meaning that the answer is x to the 7th power. And we have our multiplication rule over here for exponents. Pretty much all you do is take each exponent and add it together when the bases are the same. So we have an x and x. 5 plus 2 is 7. So then the next, we're looking at division. So what if we had x to the fifth divided by x to the second power? Well, we write it all out. That means 5 x's on the top as our numerator and 2 x's on the bottom as the denominator. And then we can start canceling, because x over x is just 1, and a 1 is irrelevant when it comes to multiplication. Another x over x, another 1, so those cancel out. So look, all my x's that we're able to pair up are canceled out, leaving me with only 3 x's, and there are 3 x's left on top, so that is x to the third power. So our rule for dividing exponents pretty much states when it has the same base. So in this case, x to the fifth over x to the second, you subtract your exponents. So 5 minus 2 is x to the third power. So here are just your exponent rules. Just a quick thing before we move on. You won't be tested on these specific rules when it comes time for the test. This is just good to know whenever you're dealing with monomials and what to do with their exponents in case you need to subtract or anything like that. So let's look at this example. X to the 7th power divided by x to the 3rd power. So that means we have 7 x's on top and 3 x's on the bottom as my denominator. 1 pair of x's cancels, 2, 3 pairs of x's cancels, leaving me with x to the 4th power on the top part as my numerator. And notice there's nothing left on my denominator, so we're going to put a 1 for right now. But just like 1 is irrelevant when multiplying with it, when I divide by 1, it is also irrelevant, leaving me with just x to the power of 4. Okay. Example 2, x to the power of 12 divided by x to the power of 9. So we skip the step of writing out the x's. This just means x to the power of 12 minus 9. Notice that I put my subtraction on the numerator because that is where the biggest exponent is located. And then on the bottom, since I took all the x's from the bottom to take them away on top, I put a 1 as my placeholder for right now. Again, that 1 placeholder is irrelevant, just leaving me with x to the 3rd power. Okay, so example 3, x to the 2nd power over x to the 7th power. Notice now my biggest exponent is on the denominator. So I have 2 x's on the numerator and 7 x's on the denominator. We start canceling just like we did previously. Now I'm left with nothing on top except for that 1, which is irrelevant, but we keep it as a placeholder in the meantime. And then 5 x's on the bottom as my denominator. So we could have easily said this is 1 over x to the 7th minus 2. Notice now my subtraction happens on the denominator since that is the part with the biggest exponent. All right, so when you have something that looks like this, so a binomial by a monomial, my suggestion, remember we're still keeping the power rules in mind, is to take it apart. Take your first part, which is 8n squared divided by 4n, and then take your second part, negative 36n divided by 4n. So now that I have 2 separate monomials, I can easily divide. I know 8 divided by 4, since that is my coefficient, is 2. Then an n squared divided by n to the first power. That's going to be 2 minus 1, which is 1. So that leaves me with 2n. 8 divided by 4 is 2. N squared over n is just an n. We could have done n times n divided by n. These cancel out. Left with 1n in the end. Okay. And then negative 36n divided by 4n. Again, start with your coefficients. I know that's negative 9. And then n over n cancels out. So it's just 2n minus 9. And that's my answer. All right, try this one on your own. Okay, so the majority of the test, actually none of the tests is going to have the actual exponent rules, but it's good to know how exponents work. That is something that we're going to lead into in the following unit. So it's a good preview of what you'll see. So, but don't worry or stress too much about those exponent rules if you still don't get them for division. For multiplication, we have gone over that, so you should be understanding those. But for division, again, don't stress too much about that. What we are stressing for this test is dividing a trinomial, which is 3 terms, by a binomial, which is 2 terms. And for that, I first need you to recall when we did the box method. We took 2 binomials, and we set them up in a box, and we ended up getting our answer, which was a trinomial. The essential parts to know here, before we move on to the next section of dividing trinomials by binomials, we're going to be using the box method, but working backwards, is that the thing that fills in the first box is your first term in the trinomial. And the thing that fills in the bottom right box is your last term in the trinomial. Lastly, the middle term in the trinomial we get by adding the 2 like terms that are left in your box. Okay? So let's see how this is going to help us in solving division problems with a trinomial by a binomial. So here's our example 1. I'm going to start by setting up my box, just like I have on the other side. And I'm going to take my binomial of x minus 4. I'm going to go ahead and place it on the top. What I'm trying to figure out is the other side length, which I don't know yet. That other side length will end up being my answer. So now I'm going to fill in my first box with 2x squared because that's the first term in my trinomial. And then my bottom right box I'm going to fill in with the negative 12 since that's the last term in my trinomial. Okay. So now we got to figure out what goes on this left side first. Basically, what times x gives me 2x squared? Since I have a squared for my x, I know I'm going to be multiplying 2 x's. And since this is technically 1x, something times 1 gives me 2. Well, 2x times 1x is 2x squared. So I know my first term of my binomial or my answer is going to be 2x. So now let's fill out the other side of the box. So we don't know what this is. So what times negative 4 gives me negative 12? There is no x, so there's not going to be any variables in my answer. But I do know that positive 3 times negative 4 is negative 12. So before I can say that this is the answer, 100% sure, I'm going to go ahead and check my work. And I do that by first multiplying 2x times negative 4 to get negative 8x. I'm filling in the missing boxes. And then 1x times 3 to get 3x. Remember, the 2 like terms need to add up to give me my middle term. So 3x plus negative 8x is equal to negative 5x. And look, that is exactly my middle term that's left over. So yes, that is my answer. So my answer, I take the sides that I figured out of this little puzzle, and my answer is 2x plus 3 is the binomial. So when 2x squared minus 5x minus 12 is divided by x minus 4, we get 2x plus 3. Let's try another one. Oops, let me go ahead and clear that. All right, so our second example, negative 6x squared minus 17x minus 7 divided by 2x plus 1. So we're setting up my box. Again, I'm going to take my binomial and I'm going to place it on top. So now I take my first term and it goes in the first box. Take my last term and it goes in the bottom right box. So I have to figure out what times 2x is negative 6x squared. If you said negative 3x, you are correct. Negative 3x times 2x is 6x squared, negative 6x squared. So now I have to figure out my other side. What times 1 is negative 7? And if you said negative 7 times 1 is negative 7, you are also correct. But just to make sure we're 100% correct, let's go ahead and fill out the rest of the box and check my answers. So negative 3x times 1, negative 3x. And negative 7 times 2x, negative 14x. I'm going to combine those two like terms right there. Negative 14x plus negative 3x is negative 17x. And that is exactly what I have left in the middle of my trinomial. So my answer is good. So the two terms now become my binomial, which is the answer to this division problem. Okay, you get to try one on your own. 5a squared plus 14a minus 3 equals, or divided by 8a plus 3. It's late, y'all. I'm going to start you off by placing your binomial on the top of the box. So what term are you going to fill in on the top left? What term are you going to fill in on the bottom right? Work it out. Move it on. And our last on your own is going to be a word problem. I'm going to guide you somewhat through it. It's still working on division. So it says the area of a rectangle is represented by the expression 36x squared minus 2x minus 10. If the length of the rectangle is 9x minus 5, which expression best represents the width of the rectangle? Keywords here, area. The area is 36x squared minus 2x minus 10. And our length is 9x minus 5. So again, you'll have to remember that area is equal to length times width. However, we want to find the width. So we would go backwards. We would divide the area by the length to figure out what my width is. So I'm going to take my area of 36x squared minus 2x. Now I'm going to divide it by my length, which is 9x minus 5. Okay. Now it's just a division problem like we did. Last piece, write a summary, 2 to 3 sentences, or a reflection. You don't have to do both, one or the other. And that is it. After you're done with your summary, make sure you end this video so that you get the full credit. Have a good day.